this is the second of my chi-squared videos. This is Mrs. Bustamante still. And we left off with our null hypothesis about our plants. And we said, yeah, that's great and all, but in biology class, it's not good enough to just say, yeah, you don't get the Nobel Prize, Mrs. Bustamante. Your results weren't that different. Okay, we actually have to prove that our results are the same or different, essentially, with statistics. And in this case, we're going to use something called the chi-square analysis. And you might ask, when do I use chi-squared and when do I use, say, standard error of the mean or something? Chi-squared analysis, we're going to use when we have counting data. So basically when we have numbers that we can count, and we use our standard error of the mean when we have averages or things that we're looking at as averages. So chi-square is represented by this kind of fancy looking X and a square on the top. And here's the formula we use to determine chi-squared. Okay, we say chi-squared is equal to, remember this is sigma, but it just means the sum of our observed data minus our expected data squared, and we really just square it so we don't have negative numbers. We don't care if it's off negatively or positively, divided by our expected data. And we do that for all of our possible outcomes. Now, you don't have to memorize this formula. You will be given it on the AP test. And now is a good time, if you don't already, to have your equation sheet pulled out. We're looking right here at our chi-squared. And you'll notice they use O for observed and E for expected. And we're going to use this table here in a second too. But that's what they mean, okay? So let's go ahead and figure out chi-squared for our experiment. We're going to use this formula right here. And we're going to use it to evaluate if anything funny happened in our data. Can we support our null hypothesis, or are we going to reject it, okay? So here, when I look at this, chi-squared for us, we suspected, or we got in our experiment, we got 775 tall plants, and we expected that we would have 750 tall plants. And then for our short, our observed was 225, and our expected was 250. So I'm going to go ahead and plug those in. 775 minus 750, that quantity squared, divided by 750, how many I expected, plus the same thing for how many I expected to be short, 225 minus 250 squared, divided by 250. Now you're going to have to use a calculator for this. These are pretty nice numbers, but you will get a calculator on your AP test, so it's okay to go ahead and use one here. So I go ahead and simplify. This becomes 25 squared divided by 750, and 25 squared divided by 250. Wouldn't hurt to put these in parentheses. Make sure we do that first. Go ahead and simplify again. That gives me 625 divided by 750 plus 625 divided by 250. And we can go ahead and start changing that into decimals. It becomes 0.833 plus 2.5. And yeah, you're going to have to do that on your calculator. We add those two values together. And that gives us that our chi-squared value for our data is 3.333. And I'm going to go ahead and box that. So that's our chi-squared value for our data here. Now we have to go on and we have to use this data a little bit more. We have to know something called our degree of freedom. And our degree of freedom is our number of possible outcomes that we could have, or our number of categories minus 1. So when we look at our degree of freedom for this particular lab, we could have tall or we could have short, right? So our D of F would be that we had two possibilities and we subtract 1. So that means our degree of freedom is equal to 1 for this experiment. I'm going to go ahead and box that. And then there's one other thing we need to know in order to be able to kind of evaluate our data. We have to know something called our p-value, which tells us about the probability, okay? And in biology, particularly for the AP test, we're always going to use our p-value of 0.05 unless they tell us otherwise. Most of the time on the AP test, they tell you what to use, but just in case they don't, you would use this 0.05 value. So now we know that. So we're going to find our critical value. And this is where our equation sheet comes into play. Our critical value is where we match our degree of freedom and our p-value together. So what are we going to look at here? This is our equation sheet, and that means you don't have to memorize it. So your degrees of freedom go across here, 1, 2, 3, 4, 5, 6, 7, 8, and your p-values go down. You either have 0.05 or 0.01. Well, I told you you're going to use 0.05 for our p-value, and our degrees of freedom was 1. That means my critical value is 3.84. So now is a good time. I would make sure you know what that is. And go ahead and write that down, that our critical value is 3.84 for this experiment. I should do equals critical value. Okay. Once you have that written down, we're going to take a quick break and come back for hopefully just one more video.